Hello. Now, in the previous segment, we just considered two charges, and we asked for force between the two charges. What if we have multiple charges? What if we have multiple charges? Let's say we have Q1 here, we have Q2 here, we have Q3 here. These are different point charges. What do we do? And even we have Q4 here. So you have this distance, you have this distance, you have this distance. What is the force at Q1? Force here. Due to Q2, Q4, and Q3. What we have to do is to just calculate the force for these individual charges. So we'll calculate force at Q1 due to Q2. We'll calculate the force at Q1 due to Q4. We'll calculate force at Q1 due to Q3. And just find the resultant force. So if we're looking particularly for Q1 with respect to all the other charges, we use the principle of superposition. So we sum up the force at Q1 due to Q2, force at Q1 due to Q4, force at Q1 due to Q3, and we sum these together, we get the force. Likewise for electric field, if we assume that here is our point P, and there are a lot of charges around, we'll still use the principle of superposition to calculate the electric field at point P due to charge Q2, Q3, and Q4. So we'll calculate electric field at P due to Q2, we'll calculate electric field at P due to Q4, we'll calculate electric field at P due to Q3. Remember always what we are talking about here, these are vectors. So superposition, the resultant of several vectors, we have to consider the direction of these lines separating between the charges, or let's say if we talk about the point, the distance from the point to the charge, we have to consider the directions. So we'll take the resultant force, we'll take the resultant electric field, and then finally we know the influence or electric field at P due to the influence of these charges. And if we're looking for force, we know the force at Q1 due to the other charges. That is basically what is done. So superposition. There are some more important things to look or consider here. If we are talking about electric field and we are talking about a positive charge, let's say this is a positive charge here. A positive charge. If we have a positive charge, what will be the direction of electric field? The direction of electric field will be outwards from the charge. So our arrows will point radially outwards. So if we have our Q here which is positive, the electric field E will point radially outwards. This is something very important to consider. And if we have a negative charge, let's assume now we have a negative charge here somewhere. How will the electric field look like? With the negative charge, the electric field will point towards the charge. So the electric field due to a negative charge will point towards the charge. The direction of the electric field will be towards the charge. The direction of electric field when we have a point charge which is positive will actually be away from the charge. These are few points that are important for us to note. Now, it is important to reiterate the previous statement that I made, that it is very crucial to understand that as long as we are talking about charges in space, and as long as we have a charge at a certain location, to get electric field at a certain point, there shouldn't necessarily be another charge at that particular location where electric field is looked for. As long as we have charge somewhere, we can get electric field at any point that is within the vicinity of that charge, because electric field at a certain point is the product of charge that exists, proportionality constant which is K, and then you divide with the square of separation between the point and the charge. Of course, you know we have to have a unit vector as well. But we don't need to have two charges to actually have electric field. You just need one point charge. And then you can calculate a certain electric field at a certain location due to the influence of that charge. Thank you.